As you'll remember from the first part of the lecture, we used a graph to estimate the solution to the equation 2 to the x is equal to 7. And we estimated x was approximately equal to 2.8. The little squiggly equal sign means approximately equal to. A much quicker and easier way to solve these types of problems is to take the logs of both sides of the equation. Usually we'll use log to base 10 or the natural logarithm, as we can evaluate these directly on the calculator. So we have 2 to the x is equal to 7. And we'll start by taking logs of both sides. So we'll write log of 2 to the x is equal to log of 7. And obviously we're using log to mean log to the base 10. Using the laws of logs, we can write this as x log 2 is equal to log 7. So therefore, x is equal to log 7 over log 2. Work this out on the calculator, write the answer down to 2 decimal places. It'll work out at 2.81. In all of the following examples, we'll work out the solution correct to 2 decimal places. And we'll use logs to the base 10 unless stated otherwise. Alright, let's have a look at another example then. Solve the equation 2 to the x minus 1 is equal to 5. So again, we start by taking logs of both sides. We can write log of 2 to the x minus 1 is equal to log 5. Using the laws of logs, we can write this as x minus 1 log 2 is equal to log 5. We need to expand the left-hand side, and we can write that as x log 2 minus log 2 is equal to log 5. So taking the minus log 2 onto the right, we'll have x log 2 is equal to log 5 plus log 2, which we can write as log 10, because log 5 plus log 2 is the same as log of 5 times 2, which is log 10. Of course though, log to the base 10 of 10 is going to equal 1, so we can write this now as x equals 1 over log 2. It'll be 1 divided by log to the base 10 of 2, and that works out to be 3.32, correct to 2 decimal places. Let's move on to the next example then. We want to solve 4 to the power of x plus 1 is equal to 1 over 3 to the power of x minus 2. So we'll start by using the laws of indices, and we'll write this as 4 to the power of x plus 1 is equal to 3 to the power of minus x minus 2. Now we can take logs of both sides. We'll have log of 4 to the x plus 1 equal to log of 3. We'll write that as 2 minus x. Using the laws of logs, this will be x plus 1 log 4 is equal to 2 minus x log 3, and we need to expand both the left hand and right hand side, so we'll get x log 4 plus log 4 is equal to 2 log 3 minus x log 3. If we collect together the x terms, we'll have x log 3 plus x log 4 is equal to 2 log 3, and we'll bring the plus log 4 onto the right hand side, so that will be minus log 4. So we can now write this as, if we just continue up the top here, x will equal 2 log 3 minus log 4 all over log 3 plus log 4. So that's going to equal log 9 over 4 divided by log 12. Using a calculator, let's work that out. Log of 9 over 4 divided by log 12, that works out at 0.33, correct to 2 decimal places. In the last example, we want to solve the equation 3 to the power of 4x plus 6 times 3 to the power of 2x minus 6 is equal to 0. We'll begin by making a substitution. Y is equal to 3 to the power of 2x. And if we do that, we can recast our equation in the form y squared plus 6y minus 6 is equal to 0. Now we can solve this quadratic in y. So we'll get y is equal to minus 6 plus or minus the square root of b squared minus 4ac, which is going to be root 60 divided by 2a, which is going to be 2. We can discard the negative value because we can't have a log of a negative number. So we're only interested in the positive solution, which is y will equal minus 6 plus the square root of 60 divided by 2. So we'll work that out on the calculator. Y is equal to minus 6 plus the square root of 60 divided by 2. And that comes out at 0.87298333462. But y is equal to 3 to the power of 2x, isn't it? So we have 3 to the power of 2x is equal to 0.87298333462. We need to take logs of both sides. So we'll write this as 2x log 3 is equal to log of, I'll just write it like that, yeah? So x will equal log of, I'll write it out in full here, 0.87298333462 divided by 2 log 3. So let's work that out on the calculator. So that's going to be divided by 2 log 3, and that should be minus 0.06 to 2 decimal places. Okay, now have a go at the multiple choice questions.